So during this tutorial, what we're going to do is that you're going really to practice on IC. Okay, so everything that I'm going to do, you will do it. It's usually what we do, but we are very used to do it with, let's say, 20 people, but not with so many people. So we'll try to be good in this. Okay, so first thing is that I would like to introduce you, Stephane, that is here. Stephane, please come. Okay, so Stephane is the main lead developer of IC. Previously, I was this one, but I dismissed because he's much better than me. So if you have any problem with the app, you can complain with this guy. And here, Stephane is going to give you this. So it is the shortcuts that we're going to use in IC. It's cool to have this because you get very efficient, and you have an overview of the functionality of the GUI. And also, we are going to need a number of files to play with. Not so much. So please go to this URL here, ic.bioimageanalysis.org. I don't know why it doesn't fit so much with the... And /image underscore training.zip. And you also need to download IC. It is in the prerequisite of the workshop. If you don't know how, I will explain it again. And also another thing is that we don't want to lose anybody. So if you feel lost in our explanation, it's not your fault, it's ours, okay? So I will slow down and so on. Okay, so we'll try to be comfortable during those 2 hours, and we are going to have a tour in the IC application. And something that we would like to do also is to sensibilize you to some traps of the image analysis that we usually face when we are working with this. Okay, so does everybody have the IC downloaded and launched so that you can have this view on your computer? Please raise your hand if it's done, or very few people. Okay.
If you have any problem, just touch your hand. I tried to download some sample files, but I couldn't see the URL.
Okay. Okay. Yeah, it should be fast. Okay, so for the images, you just take this and you will have the images, but we will just need a few, let's say 3 or 4. Okay, I think for the beginning, as you are downloading the app, I will do some trivial operation. Oh, sorry. The beginning is always difficult because of those prerequisites. And when you are not so many, we distribute an USB key. That is cool with the USB key is that if you put it on a Windows or on a Mac or Linux, the distribution of IC that is running on the USB key is able to morph to adapt to the operating system that you are working with. It's okay, so I guess you are downloading. So I will show you a number of first things about the GUI of IC. So here you have this main toolbar, and here you have the inspector. So when you open something, like this image, so in the training you will see those images. I just opened this image. So the first thing that you can see is that you have the ROI that are included also in the image. So it's something that we do in IC is that if you do something on your images, we store your changes in an XML file that is beside the original file. So we don't change the original metadata of the file. We don't touch it because of the safety of your data, traceability, and also because we don't want to rewrite all the time the image because we don't know how long, how big it will be to write it. So here you have the ROI, but they are beside in the directory of the image. So I took this one. There is an image a file here, p7.xml, and in this you have all the extra information that you created, like the pixel size, the channels, the names, and the description of the ROI. Okay. So there is something, because you're all image user. I guess you just discover IC now. Yeah, that's right. Somebody knew IC before or not? Not at all. Okay. So, great. So there is something that you always miss at the beginning. Where are the commands that I need? So if you have this sequence here, just this image, if you want to play with the basic functionality of this sequence, there is no big menu like in image. We didn't choose to use this. So you have this tab, and here you have the basic things like duplicate, convert to any data format. You have the crop, the canvas size, the image size. For the channel, you can extract a channel here. You can remove, merge. You can do whatever you want. But there is a more natural way of doing things, and I say is to type them in the search bar. So let's say, for instance, in this image, what I would like to do is to extract the channel. So if you type EXTR in the search bar at the top, you see that the commands are following here. So if you want to extract all the channels, you just type this and you click extract all channels, and it's done. Okay? And if you want to reorganize the view of the image, you just press Shift J, and this is going to put all the images in the grid like that. Shift G, sorry, like grid. Okay. If we use a fluorescent image, it's more interesting. Like I will take this one. So we again see the ROIs, and once again, if I extract on this, I do that, and now I have all my channels that are extracted. Okay. So now you don't even know the application. How would you merge it back? Simple. So you type just merge in here, and you will see merge channels, but you can also merge in Z or merge in T, because IC is, from the beginning, is 5D. IC is newborn, okay? So the data structure is 5D. There is only one data structure, and it's completely 5D. So here we want to merge a channel. You click here, and if you want to rebuild, for instance, the first image P7, you select the channel 0, the channel 1, and then the channel 2 of P7, and here you have a preview of what it's going to be. Okay? And then here, if you press OK, you will have the original image that is built back. And then for all the basic things that you need, you will never need to search for it. So if you want to crop the image, you create a rectangle like this. So it's in the ROI tab here. And here you type crop, and you click, and you have the crop that is performed. Okay? So we really try to make it easy. Okay, so now I'd like to show you some extra stuff that we have. It's possible when you are playing with an image. So here you can close everything, and this button for the Mac user, maybe you are not used to it. It is the application button. You have the same on the Mac, and here you can open back the images that you just opened. So if I go back to this image here you have on the right the histogram of this channel. So here it is the channel 0, here you have the histogram of the channel 1, and here's the histogram of the channel 2. Okay? And you can play with them. So you want to enhance the view of the green channel, you have 2 bars to delimit how the rendering is going to perform. So it's going to be performed on in between those 2 extrema that you provide with this blue bar and this red bar. And if you press the green one, you shift everything. If you double click on it, you can set them manually. Okay, so it is a direct application of what we've seen this morning. You have an image, it can be in 8 bits, 16 bits, 32 bits, on double, whatever you want. They need to be translated through this lookup table for the visual information that are in 8 bits on your screen. So here you have the lookup table that is used for the green channel. But if you want to change this, let's say you want to represent it in cyan, for instance, you just select here the lookup table that you wish for this channel. Okay, it's independent. So you can recover exactly the look of the image that you had even within your microscope. And what is funny is that you can actually create yours. So if you click on this lookup table, you see that you can create new points. And you can even build an RGB lookup table. You just need to click on the red things or in the blue one. And then I'm completely destroying my, my rendering, but it's very informative. You will see just after I will show an application of why do we need this tool, why do we need the lookup table, because it may look strange. And by the end of this talk, you will also understand why we need the noise in the images, why it is so important. Okay, and if you want to disable the rendering of a channel, you just tick the channel. Okay. So the other thing concerning the viewer is that, okay, I'm watching this and I want to extract all the channels as I was saying. And then for all those one, you can go back to a gray view if you wish. So of course you can save your own lookup table if you always use the same. It's easy and they will be recalled automatically. If you just close an image and then you reopen it, we save the metadata and also the lookup table, so you will have the same rendering when we load it back. Okay, so here I just split the channels, and now I want to observe what happened here in my image, but also in this image. So it's what I showed in the lightning talk, where I was faking to stress. And here you put the #1 lock. And now those 2 viewers are linked together. So you may ask, why do we have the #2, 3, 4? It's because it's possible if you have a 3D and time stack, you can synchronize, let's say, only time, so that you can see in a viewer a specific Z, and in another viewer another Z, but you keep synchronizing the T. And the same for synchronizing 2 time points, but not Z. And if you want to affect the channel directly, you can just press 1, 2, 3, 4. Or Shift 1 if you want to affect it to all the different viewer of the app. Okay? If you have questions, of course, you don't hesitate to ask me. I can even drive the tutorial to questions that you may have. There is another point, we saw it in another presentation, is that if you right-click, you can rotate your image. That's very important because we've seen a number of biologists. They take their images and then they rotate it. But through the processing, you lose the noise of the image. and they don't consider that it's going to be a problem for us afterwards. So here in the viewer, you can rotate it, but you actually don't rotate your image. But it's cool if you want to find back a geometrical clue that you were missing. Okay. And then when you have your yeah, okay. Just to show you also in the lookup table, if here you want to go to this kind of lookup table or this one, this will be applied to the viewer. Okay. So I close everything because I want to go now to the 3D. So in the images that we provided to you, there is a 3D stack that is here, 3D stack.tif. So you take it and you drag it in the viewer. And you have this view here. So in IC, we decided to put sliders on the side when it is Z. And if this sequence is in time, you would have a player. And it's very easy to convert a stack to a player. In the sequence operation, you just press convert to time, and now you have a time player. And here you can specify the number of frames per second you want to see, and this thing is rolling. I need to enhance the contrast for the beamer. Okay, so if you put it back as a stack, here you can switch to 3D just by clicking in here this box. So I click to 3D here, and now I should have my 3D rendering. So I'm going to complain. I'm Stephane. Oh, why? Oops. Sorry, I close it. Try again. Oh yeah, it's because I'm connected to the screen. Okay. Because you have we are using the VTK, so it doesn't react the same if you are connected to a beamer or not, because it's not using the video card the same way. So here I'm completely on the CPU for the rendering. And this is a recasting rendering, meaning that it considers the transparency of your environment to propagate the illumination. And you see that the lookup table that you have in 2D, they are consistent with the viewer that you have in 3D. It may not mean a lot, but it was a little bit difficult to do. And here, if you want to have another view, you just click this view here. It's written duplicate view, but no data. And then you have a second viewer, and for this viewer, you can change the way of representing the data. And you can also check not to have the linear interpolation to be, when you have little stacks, it's cool because you really see the data. You don't see fake object or phantom object that are created because the interpolation is creating roundness with the different pixels. Okay. So I will go back to the 2D, and I will go back also to my first image here. So you see that I'm reloading it, and I keep the lookup table that I had at the beginning. But if you want to go back to the original, you just set the first one. So this morning we told you that Jpeg is bad, and it is incredibly true. So here, if I have this image and I take my green channel and I push it a lot, you see the kind of background that we have. So there is a lot of squares, and of course the square doesn't exist. It's just the system is creating the square to simplify a bit the data, and then it's more efficient to save the image. Okay. So as image analysis, we always have people that are coming with JPEG, And now, for the last 3 years, now they are not coming anymore with the JPEG because they understood that TIFF is great and you can still compress it, but like with a zip file, you know. So it's not a lossy compression. But there is a new problem coming now, is that people are now providing images from the scanner. And those images are, for most of the scanners that I've seen, they come back to JPEG because they are so big. And in fact, people are not really interested in the analysis of this at the moment. They just want to have like a virtual microscope, which is completely a problem at the moment. So each time we say don't use JPEG, keep in mind that a number of commercial softwares, they do JPEG. I will say behind your back. Okay. So usually I have a lot of blah blah, but I will remove it. And a lot of things about this. Okay. So I just want to make a point about the histogram, because usually people don't know how we build it. So here we have an image that is 3 pixel per 3 pixel with 2, 3, 1, 0, 1, 0, 1, 0, 2. And to build the histogram that is corresponding to this, we just count the number of pixels that are from a specific intensity from 0 to the maximum of intensity, that is 3. Meaning that here our image, the dynamic is 4. So if I count the number of pixels of 0, we have 3 pixels. Oh, yeah. So we have 3 pixels of 0, that makes this first thing. We have 3 pixels of 1, that makes this thing here. 2 pixels of 2, it is this one. And 1 pixel of 1, it is this one. Okay, so in fact, the histogram, it's another representation of the image where you lose the space information of your image, but it still represents a lot of data over the image, and we will see how we can play with this. So when I was young, I used to have this kind of monitor where the pixel was on or off. So when I had images that were grayscale images, I knew that the monitor was really lying to me. And now we are playing with those kind of monitors, the one that everybody has here. So you have 8 bits for the blue, 8 bits for the green, 8 bits for the red, meaning that you have 256 shade for each channel. But the problem is that our camera that we're using in biology, they can be 12, they can be 14 bits, and maybe more now. So in fact, we are facing the exact same problem as before, but now we don't really know it. Before it was obvious, now a bit less. And here, for instance, we are using an atomic force microscopy device, that is a schematic here, to scan the blood cells that are represented here. And what we want to know is do we have those things that are called knobs on the blood cells? And when you look at the image in 2D, you only see this because it is a 16-bit image, so the dynamic is too big to see the little knobs. So if you show it in 3D, you have your 2D image here in 3D with a good shading, you start to see this. So a good solution to find the knobs that are in here would be to use what we saw this morning. It is called the background subtractor, you know, with these famous rolling ball things that you saw this morning. And during the talk, I was trying it to see if I didn't fall in the same trap as the one that we are going to face. And in fact, no, it doesn't help for this problem. So if you can open this image here, knob test 16-bit per pixel.tif. So we have the image here, and here you have what's the navigation, and here you have the histogram. So my first question will be, can we have a close look at the background of the image to get some information? And you will see we will investigate on this image, it's quite funny. So here, I want to see this area. So what you can say about this area, it is that the background should be the maximum number of pixels that are about the same intensity. So if I want to see only the background, I take the boundary that are here, this red one, and I go to the maximum that is here, okay? So I switch to this red thing, and then I take the blue, I switch to here, and now I have a look to my background that is here. Okay, so there is something obvious that you can say about the background. In fact, we have, let's say, 5 things that we can say. Can you tell me quickly? It would be so good if we can interact a little bit because I feel alone. Okay, so we have we have this horizontal line. So I have a secondary question for you. So what does it mean? Oh, because I need to explain what is the atomic force microscopy. No, but you will see, you can still answer us next time. So you have your sample, you put it on plate, and then the atomic force microscopy device is going to scan it like that. So now that you have this information, and every pixel that we see in here, the intensity, the more you have intensity, the higher you are in the sample. Meaning that if I put back the image, the original image, so you see it's cool to be able to have several viewers. Up. You have an idea of the shape of this. So here it's going to be the top, and then here we have kind of a donut, okay, I will say. So here we have those stripes. So I ask again, could you tell me why do we have those stripes? Yeah.
Would it either be an unevenness in the surface that is plated on or a natural jitter of the tip of the atomic force?
Yeah, exactly. And it's cool because you say the 2 possible solutions. So in fact, it is the noise of the apparatus, okay? Because when we're doing this thing, it means that when we're going back to the next line, it's not going to take the same Z as a reference. So it's very cool because if I compress this image in JPEG, this will disappear. So I cannot tell you anymore when I see a knob, if the knob is over the noise or below the noise. I need to create kind of a model and to measure the noise of the apparatus to know if when there is a good measurement, it's okay or not. Okay, so here it's physical to understand why this device is not going to go to the same Z because of the mechanics. For the camera, it's the same, but it's going to be through the electronics, it can be through the tissue, it can be through, well, this noise exists. I have another question for you. Do you believe the scan is that way or that way? Or is it going to do this, or does it go back and forward? Both direction here. You agree? Okay, you say both direction. No, you don't agree? What would you say? One direction? Okay, so for the one who say one direction, which direction would you say? So from here to here, so for your left to your right, or from right to left? Or you can also say, I can't say. Okay, do you believe we can say it further on? Do you believe that afterwards we will be able to answer this question just by this image?
I think I don't really understand how the technique works, so I don't.
Okay, okay. Well, I will keep going and you will see the answer of this. The idea is just to understand if the apparatus is scanning this way, or both way. That's all. Okay, so we can see also some dust, and in fact, if we plot the profile of this, we can also see that the plate is bending like this. Okay, so this is just a little bit of things. We didn't process anything since then, and if you were using a rolling ball something to remove the background, you would have missed it, and that would be a problem. Okay, so now we have this lookup table, and there is something funny that we can do with it, is that you can produce false 2D rendering with false color, and usually you're scared about the usage of false color. But for publication, it's cool because it's not always possible to put a proper 3D figure that is showing what you want. And here, if you go back and forward in your lookup table representation, you see that the knobs are appearing. Okay? So in fact, what we are doing here is that we are completely artificially, and people could discuss about this, I'm sure, changing the dynamic of the pixel from neighborhood pixel in intensity, neighborhood class of pixel in intensity, I would say. Okay? So now we have those dots that are appearing. And you have a very nice effect if you are moving the boundaries here, because the things, of course, are going to roll. So why is it rolling like that? It's because when I play with this boundary, the lookup table that I created here is going to be applied from here, this intensity, to this intensity. Everything that is up to this bar is going to receive the same color that is the final color here. So here it is this white thing. Oop. So if I put gray, everything is going to be gray. And, well, it was just to mention this. Okay, so now what we can do is switch to 3D. But you agree that it is not the same 3D as before. It is 3D, an extrusion 3D. We call it an elevation map, or an 8 map. So I will do it with this image here. Before I will switch to this kind of lookup table, so it's easier to see. I don't go to 3D VTK, but I go here to this one. And now I have my 3D view of my sample. Okay, so usually when you go to 3D, you really believe that you apprehend everything and that you can really answer all the questions. Oh, by the way, I forgot to ask you another question, so I will hide it a little bit. You see all those things that you have here, all those stripes. Do you believe that they propagate into the sample? Because here I don't see it, okay? But do you believe that they are into the sample too? And if you provide the proper answer, you will have the answer to, in an image, is the noise only in the background or everywhere? But you know everything. So he's saying, you say that it is everywhere, and you are absolutely right. And here you can really see it in 3D, because the stripes here are visible thanks to the shading of the rendering. Okay, so you have those stripes, meaning that the noise is everywhere. Auxiliary question for you. Do you believe that there is a noise between this position and the very next one? Yeah, of course, but this time I can't tell. I cannot measure it, and I don't have model for it. Okay, so you have this image here, and if you like it, or if your boss say, okay, go with it, it's cool because we can publish in Nature right now. If this is true, we can publish all together. So you would give me your name at the end, okay? And we have a good one. Because it's not possible. This image is not natural. There is a problem in it. Can you tell me what is? And you see from the beginning, we didn't run anything, not even a blur, nothing, just observing your data. Because if you do something with this data, you're going to have something completely wrong. So there is something not natural in here. Can you see it? How many eyes do we have? Okay, I rotate it a little bit so that you can have a better look. Yeah, here now it's obvious. No? Yeah, that's it. We have a problem with the slope. And the slope that is here, for instance, that is within the sample, it's completely straight, okay? Meaning that well, it's not natural. And you know why we have this? It's because, remember, the aperture is like that. So you put your sample here, and then you have your thing like that, and the probe is touching the sample here. Because the probe cannot be like that, because it will go into the sample. It cannot be like that for the same reason, so it has to have an angle. So you go like that, and you do this. But if I have something very cleanly, sorry about the English, if you do this, here you have a shadow area. I cannot scan what is here. So now you have another answer. You know that this sample has been scanned from here to here, and there is no go back and forward. And there's a second thing that is cool with this, but I don't remember. Oh yeah, you know the angle of the probe, and oh yeah, the very big problem is that in our question here, we want to measure the density, the number of the knobs, those little things that we have in the sample. So you can be sure that if you don't say this, after 2 years of work, the biologist is going to come to the boss and say, okay, I have a fantastic result. The cells that are very bumpy, they don't have knobs, and the other have knobs. And it will be only an artifact of this problem here, okay? So IC is created to help you understanding deeply your images and navigate in it and making Star Wars in your 3D stack with a plugin that is designed for this. It's not a waste of time. You can really see things that are funny. Okay, so we are done because we've been in 3D, and 3D, it is the ultimate goal. Now, of course. So we go back to 2D, sorry. So I close this. And here I go back to 2D, and I will put back the original thing that is here. So I have a question for you again. We saw that here we have all the data, and here it is the background. You agree? This peak was the background. So my question is, what is below the background? Because there is something here. So is it the basement of the image or something? So how would you do to see where is located this data? Come on, don't be shy. It's always an easy question. So you just take this boundary, you put it here, and this one, you put it here. And you see nothing. You unzoom a little bit, and here it is. It is this thing here, okay? So your background is most of the time 11,000, and in here, if you zoom a little bit, you see that in fact the apertures just dive into the sample, or maybe it is the initialization, I don't know, but it was this thing that was here, okay? And in fact, there is a lot of other things that you can find in this image, but I will stop here with this example. But it was just to convince you that if we put this lookup table thing, this histogram, this capability to play with these things, it's not really for nothing. So, okay.
What's the shortcut for Zoom?
It is this thing here. But yeah, if you can't play with this, here you have a zoom functionality. And you can go to a specific one, but if you are using a trackpad, usually, no, not on this one, but on this side, you also have the emulation of the mouse wheel. Okay. So you are listening, or you are doing the same with your computer? Because if you are not doing the same with the computer, I can go fast, I don't know. Who is doing at the same time? Nobody? No one? Okay, great. 2. 3, 4. Maybe because Stephane is there, so you are helping people. It's great. Now I'd like to show you something, because this morning we saw it too. So I take this image P7, and what I would like to do in this image is being able to say that here we have more neurons than in here. So when I started my job, you could publish, you could say, okay, but you see it's obvious, so don't ask me, and so on. Now they want numbers for everything, and they're right. So the first thing in here is that I will use a plugin that is called the spot detector. So I made it, but you will see, I will say it's not a good one. So I'm forgiven. And then I start the detection. So it works because, in fact, at the beginning, I had this image to work with, so the parameters are good. And you have those spots that are here. So I have an obvious question for you. Do you believe that they are detecting the proper neurons. You see, we are above the tool. We don't mind about how do you do this and so on. Now the question is, what do I do with my data? Maybe they are completely wrong. So to help you, I will duplicate my view. I will synchronize it. And in here, I will remove the layer. Okay, it is this button when you don't want any more layer. Or if people are catching up, I will show you something that I like. No, okay, I will do it later. Okay, so sorry. So I have a better close-up to see if it fits the detection. So do you believe it's okay or not? Okay, I will ask again like that. So you say yes, it's okay? 1, 2, 3, okay. So, and some people say it's not okay? My question is, I have all those neurons here, and I'm detecting them automatically. So I'm just asking you if you would be confident in the result I'm providing. Okay, so you're absolutely right, because of the first thing is that thanks to the histogram, you see something obvious, is that the image is not captured well. It has been saturated. So if you do this, because you want to go back to this proper dynamic, you see that the color is changing. Of course, it's because this is a bright field image, so we need the 3 different channels synchronized. If I do this with the green and I do this with the blue, I still have a shift. So what is cool is that if you maintain shift while you move, then you keep the consistency of the color balance. So now, it's easier for you to tell me if you agree with the detection. There's something else that I could do, is being here and make it blink, like that. Okay, so I put it a little bit like that, a little bit like that. Or I do the same here. You say it's a good job, okay. So there is something that I do usually when I have time, is that I always have people that say, no, it's not working. So I put a paper here, and I ask 2 people to come and to agree on what they're going to detect. But at the time they want to agree on what they want. So they say, okay, I want to take this one, 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 this one. So usually I'll take the boss and the trainee. And the trainee say, yes, boss, okay, I will do it. And then I move a little bit my image, like that, and I say, okay, so there is a new problem because you didn't discuss on this one, you discuss on the previous one. So I put the first one, and the trainee comes. And I ask him, okay, just pick with a pen where you find the proper neurons. And then he's doing this thing. The boss is not watching what the other is doing. And then the boss is coming, and he's doing the same. And then I take the 2 papers, and I put it like that. They are different, and everybody is laughing. But it's not here that it's cool. It's that after I tell to the boss, okay, do you agree to correct your trainee? And then I put the paper, and then he starts correcting. But in fact, I put back his own paper, and he's correcting himself. And why? It's because of this. You see here, now that I put the marker on this, you don't have the same sensitivity. Before, you would have said, okay, this one is okay, 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 okay. You would not have care of this one. But because of the presence of the marker, you now want it. But here, you would have never asked for it. And you may say, okay, maybe it's wrong. So before, this plugin was editable. So you were able to change a spot to say, I don't want this one, I want another one. And you see, it's less than a second to detect everything. And the biologist came back to me, he told me, okay, I'm very tired. I spent 8 hours on your system for 1 image. And I still have not the good results. So I said, okay, you are very interesting, and I will track what you do. So I keep a record of everything that she deleted and I did. And what she was doing is this. Okay, so here I want this one, this one, this one, adding, 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 going here, going around, coming back, and removing what she added. And always trying to have the very best result. Because the problem is that the samples were difficult to produce, so they really wanted to have a very good scoring. And now I explain to these people, this detection here is wrong. But it's wrong, let's say 90%. If I have a score of 90%, it's okay. Never try to correct it, because you're going to indeed making the thing worse. And because it's very easy to do this, concentrate on producing this sample, and then we can compute 100 images if we wish to see the result of this. Okay? So I keep having my question. You are interested in this, or you want to go to some other functionality? No? Okay, so I will create a ROI here. And by the way, I will show you the different kind of ROI that we have. And another here. Or you see, I can do something like that, but after, if I want, I click here and I can refine it. Okay? Or if I want to create my ROI on a specific channel because I have better eyes in red, but I'm sorry, my example is completely wrong, but you could do this and then play with this thing. And this would affect, whoops, the other ROI. Oh, by the way, if I mess up, I go to the history, and then I can go back to the point I want. Okay, but it's not only for the ROI. It works for a lot of different things. Okay, so I have my two ROIs here. And by the way, you can have a lot of information just by having the ROI that are present here. Here you have the perimeter, the area, and you see that if I'm playing with this, they're updated. And in IC, maybe you've seen that everything is smooth and everything is sent to background computation so that the graphical user interface is always fluid. So when I'm doing this, if I want to compute something big with a large area or a large number of ROI, we don't care because everything is delayed. And here you can select what you want to see live. Let's say you want to see the max intensity of the channel 2. Now you have it here. And if you move your ROI, you see that it is updating. Okay? And even if you have a big image, it will always be smooth like that. You can change the color of the thing. So if I want to make it red, and as a lot of time you will export to R or you will export to Excel things, you can rename your things. So here, double click here, and you say here it is my high density ROI, and here you can say it's my low density ROI. Okay. And now, when you process back your data, so I lost my window. You press Start Detection. In fact, the plugin is a big plugin. It's creating the result for you in an output folder. And if you want, by the way, the documentation of this plugin, when you type spot in here, when we launch the plugin, instead of left-clicking, you right-click. And if you do this, you go straight to the documentation that is on the website. Well, a little tour on the website. So here you have a summary of the plugin. You've seen that when you launch IC, you see a splash screen showing a plugin. It's not really written IC. It's written IC, but a little. We try to put forward all the plugins that we have. And in the website, here we put the publication because we have a problem. We don't want to be published. Or to be cited. What we need is the plugins that are using IC to be cited. So here we put the publication of the plugin, and we want the user to understand that he should not mention IC, only the plugin. We don't exist. And here you have the different user review. But this is serious. I mean, this is something that we keep changing. Now we would like to monitor if you are using, let's say, 10 times the same plugins within IC. We don't need to have the numbers. IC will pop up something saying, okay, don't remember that you are using this plugin. This plugin, it is this publication. Don't cite us, cite the publication. So it's you first. And here you have all the documentation, here all the rating. And by the way, everything that we're doing together in this tutorial is here. Just a quick tour. You have all the resources here. So the plugin list with all the current plugin that we have. You have all the script, and you can even see the look of the script. Let's say I want to call an ImageJ plugin. So you have the script that is here, and you write image.run, and you can have your ImageJ plugin working. And you have also the protocols. So it is a graphical programming. If you want to do, let's say, the same thing with ImageJ. Okay, it's not. I don't see examples. But if you want to, let's say, split channel, for instance. Well, you see, I can't find it on the website, but it's easier on the application. If I want to split my different channel, maybe I'm not. No. I'm sorry. Because here you have all the online plugins, and here you have the online protocol. And if you type detect, for instance, you can have a protocol that is doing the same thing as we are doing, but in a graphical way. But we will go back later on this. But this resource is also on the web, okay? So if you, for instance, you create a graphical thing like that, or if you create a script, it's you just need to create an account on the website, and then you put your things. But you don't really need to be a programmer. If you create a protocol as a biologist, other biologists may use your protocol and then cite you. And there are versions, so you can update them without destroying the one that you created before. Well, so I'm sorry because I leave this this thing. So here I go in my image folder, and if I take my p7.xls, here I have automatically the result that have been saved. And here I see all the information about my experiment. And if I want to see the density, because it was my first question, I type density here. I'd say that's equal to this over this. And now I have my density for the two, and I can say, okay, there is something significant. And I have this, okay? So usually if you do the same thing, I ask you your numbers. And when we do this, we see a lot of differences, meaning that for the high density, all the value that you're going to provide, they are going to be very jumpy. And for the low density, they will be about all the same. So why we do have different results? Because in fact, we are working with the same algorithm. We didn't change any parameter, but we have different results. So do you have an idea about this? So, okay, I get it. It's just because of the shape of the ROI, because everybody is going to draw in a different way. So that's why we record also all the ROIs to be able to reproduce all the pipe. So if you are in a high density area and you shift a little bit your ROI, you have a huge effect on your data. In the low density, you don't have this problem. Okay. So now I will show you what has been shown this morning. It was the second talk, I guess. And it's very interesting because to us, it has bring a question some time ago. So if I take this image that looks like the one that we had this morning, the question that we had was how to be able to count the green spot within the blue cell and make it fast. So this morning you saw all the different steps to do this. And with the spot detector, It's possible to do it very simply, but you will see it's not a quality. So in the input, I say here that I want to detect the green one. Oh yeah, no, I just say I want to use this sequence here. If you wanted to batch everything, you go to batch, you select a folder, and then it will batch over this. And then in the pre-processing, you say that you want to find things on the channel 1, that is a green. Then the detector, which is here, you tell it that you want to detect a signal that is bright over a dark signal because you are a fluorescence. Here you have the scale, meaning that you want to detect a specific size of particle or spots. And here you have a sensitivity that is computed automatically. It's a wavelength adaptive threshold that is computed with the noise of the image. So that's the reason why we need the noise of the image. And then you can put the region of interest. So in our case, what we're going to do is we're going to create it from a channel. That is going to be the channel blue. And I can test it, and you see that I have my rows that are created here. And I'm facing exactly the same problem as the one that you had this morning, meaning that this row, for instance, so it's a mask, okay? So I don't know if you see it well, but it means that this is only this part that is drawn, that is considered. This thing, it is a bounding box, okay? And thanks to the history, I can go back to my original position. So here we have a problem because we have 3 cells that are together, and we have also another problem is that the one on the border here, they are not consistent in the analysis because they could, you know, all the spots can be on the side of a cell, so we can't use it. And after we have filtering for the size and for all those things, and then you have this output, and finally the display. So when you start this thing, you see the display is important because you get someone with too much data. And here you have the number of detection per cell. So it's okay, we've made it fast, but it's less good than what we saw this morning, because this morning the guy was able to split those things. And here I'm not able to do it. I'm not able to do it because this spot detector plugin is far too big and it's not possible to break into it. So it's much better to have smaller plugins that are not doing such a number of things, and to be able to add here easily step of watershed, of error, delayed things, okay? So to avoid this kind of problem, it's always possible to use a feature in IC through the plugin, the GUI, but you can also access to the functionality of the plugin, I mean programmatically. So if somebody tell me something like, your plugin is cool, but you didn't foresee that I will need to change the sensitivity by the time in my T sequence, because this detector works in 4 dimension. So this guy is going to tell me, I want you to make your GUI more complicated so that now I can put a formula or I can have a tick something because I want to do my very, very specific thing. So for this guy, I will tell him, okay, it is too specific. So I write a plugin for you. But I will write a script. And then here you go to the resources, online plugins, and here you have the script. So if I want to detect the spot and change the parameter in time, I just click on it. I wait a bit, and now this script has been downloaded from the web. And we have here access to the detection things that you saw. It is this line, detector.detect things in the sequence. But then you can add extra code to add your extra feature and not break a kind of continuity or reproducibility of the GUI. Because if you change your GUI on a plugin that is used a lot, and sometimes people ask you to change default parameter, then you are facing a problem. So it was a problem in IC, and that's why even instead of using the script, Alexandre Dufour, that is in our lab, talked about making graphical interface called the protocol to create things graphically and without any I will show you this. Okay, so let's say I have an image and I want to extract the channel. Okay, but I want to do something specific in each channel. So the idea here is not this one. Okay, if I take this image and then I play my protocol here, I have the different result that have been created here. So I have my input image. If I double click, I find it back. I have my channel 2, my channel, my different channel. Because to build this, you just take this input and then you wire it to the next box, like this thing that is going to extract the channel. I'm just watching if you see it. And then you can attach it to a display. So some of those boxes are smart because they can adapt to the input. And some of those boxes are, some parameters here are constrained. So you need a number to enter here, you need an image, you need something with 5 dimensions, you need a ROI. Okay. So it's very, very easy. And if I want to connect this thing to here, for instance, well, it was a message, it's not possible. Okay, the variable I cannot connect, but here I can connect. And Stephane will show you a little bit more the protocol through a complete example. Okay, I'm completely lost with the time, and here it's not a good one. So we still have, it's, Okay. 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 So now it's going to be a little bit, what do you want? I like to do this, it's quite challenging, and we can do it. And by the way, are you interested by the tracking things or not? Or because we have some tracking stuff that is quite okay. So if you want a little demo during the time you think about something that you want to ask, I will show it to you. So here is a problem that we were facing. We have this image here. Oops. So it's not a difficult one. And what we want to do in here is to track the vesicle here, and we want to track them individually when they are going into the cell. How do I open it? I just took the particle tracking folder. Yeah, within it you have a lot of images, but we are using bioformat as an input, and it's done an excellent work. So we do not even deal with this. Yeah. And if you have, here it's projection 001, but if you have fancy things like T001 or Z001 or C something, we parse it to put it in the correct dimension. Okay. Oh, see, if you are trying to following up, this time it's going to be hard because I will click a lot. Okay, so here we have the vesicle. So the target here is to be able to track each vesicle individually, because if we get the speed, we know which transport they are using. If we know the transport, we publish. Okay, so it's very simple. I like my logic. And here I will first need to make a spot detection again. I'm sorry. There's another plugin that I was just saying. And here I will need to detect this thing. The sensitivity I will put much more. I don't even remember. Let's say this. And again, I don't want to put it everywhere. So I will draw my ROI, let's say here. And to show off a little bit, I will always keep the video running like that. So you see that IC can do several things at the same time. And then we have this filtering. Output, I don't want any output. And it's cool because I will show you another historical problem that we had in IC. Here there is something that is called export to swimming pool. It's a very crappy something because before we were able to speak between plugins, but if a plugin runs something and then is terminated, how another plugin can get the result and play with this? So we created an area that is called the swimming pool because we wanted to have a joke. So any plugin can take an object, put a label on it, and throw it into the swimming pool. And you can ask to the people around the swimming pool that are guarding the swimming pool, you can ask them if something has been dropped in the swimming pool. And then you can take it, and you do whatever you want with it, and you put it back in the swimming pool. And by the end, there is a plugin that will show that the final thing that is in the swimming pool is a result. So it was a previous design for a very multi-agent system. Like you have a big swimming pool, you have 10 workers, and people are doing things with the objects. And now, thanks to the protocol that you saw, it's something that we completely dropped because when a data is produced, it is directly sent to the next plugin. But it's still funny for the multi-agent things. So I run it. This thing? Yeah. Yeah, 140. So if you put 100, it means that you are fully confident in the measurement of the watt estimator. If not, you amplify or you decrease the number of detection that you will have. And now I have this result. So look at this, I'm very happy. Why even should I need to track this? Because I have all my results. So the problem that we're facing here is the problem of tracking, that here you have those dots that are appearing, but for specific t. There is no connection in time, okay? There is no wire in time. And it's difficult because if you look at this location here, for instance, it's blinking a lot because the detector, we cannot be completely confident in it. Or maybe because the vesicle is going deep in the tissue, we don't see it anymore, maybe it disappeared behind something. So in fact, we can model the confidency that we have in our observation, and this will be reflected in the algorithm. Okay, so now I don't need any more my ROI, and I will launch a tracker. So we have a lot of different trackers, so I need to find the proper one. I don't remember, spot tracking, it was obvious. Okay. So here I say that I want to work with my last set because the swimming pool is always accumulating the different results that I have. And here I'm going to estimate the parameters, and the tracker is going to ask me how is my sample. Is it mainly diffusive? Is it directed? Is it both directed or diffusive? And here the system is asking me if it should evaluate the parameters for each particle individually or globally. So I don't touch anything because I want to be naive, and I know that it's directed, but I don't want to do it. And then I launch the tracking. So it's cool. Before it took 5 minutes to perform the tracking, and now it's done. And now I have the tracks that are displayed on my sequence. And what is funny is that IC from scratch doesn't know about tracks at all. But there is this plugin, tracks, that enables the type tracks. So now you can play with tracks. And this plugin, Track Manager, know what is tracks. So it depends on the tracks, and it can display it. And here you have this view here, where you see the different tracks. And when I click on it, you see it selected here, but you can do it the other way. Oh, okay, not this time. And here you have backslashes, meaning that the tracking created a detection somewhere where the tracker thinks that the detection missed something. But it is something that you can tune. You can say, I'm 100% confident in my detection, so I dare you putting a detection in my set. Or you can say, I'm really not confident, and then the system is going to add a lot of them. You can also put the probability of appearance of the particle. I mean, you can tweak it. And so here you have all the tracks. And if you add a tracking that is able to deal with lineage, you would have things like that. So here I'm editing my tracks, but they could split like that, for instance. So you can edit it. And here you have another column where you can put other things, and those things are plugin too. Because let's say that you want to change a little something, like the color here. You don't like the color. Or you want to put this kind of color to see what is true and what is virtual in the image and what are the links. So we don't want you to recode everything. We want you to be able to only write the little piece of code that is here. So that's why here we have the tracking plugin, we have the track manager plugin, and all those things that you can add in here to monitor your tracks are plugins. So if I want to put a time clip, for instance, and now you see that the tracks, they have a tail. And you can also now display the future, so you have the current position and the future and the past. And now over this, let's say I want to place a gate with a ROI, so that I only see what is in the ROI, but I can have a number of them. I want to see what is here, but that's all. And now I want to know the speed. And I have this thing here, but it's only showing the speed of what is currently seen. And if I pause my system and I go here, and if I move my ROI, you see that the thing is going to be completely interactive. So it's not the plugin that has to deal with it, it's just that we call it when we need to reprocess the data. And you can have another one, because when you see everything about the tracks, at some point you want to go back to a global view to understand the global scene. So to do this, you use track processor flow, and you put something more reasonable, and you can play it back again. And now you have a kind of forecast to see how your tracks are moving. And this is going to be also again interactive with this thing. And it's possible to put the graph on the sequence, whatever you want. Okay? But it is something that you can do with sometimes I have doubts, because if I go in a way, I will have 10 minutes on it. But I would have liked to show you that with the ROI, it's possible to have tools that are going to help you with the ROIs. And even here, for instance, I have my thing. I want to customize. I want to have the color bar. Okay, so I just click in here, and now I have the color bar. Oh, a little story about the plugin install and direct run, like what you saw. Before, people had to go in here. So in this, how you say, jigsaw puzzle piece, and here you have the list of all the plugins. And by the way, it is here that you can select a private repository if you want to be outside of the public loop. And people had to go here, for instance, and then click install to have the plugin. And it was far too much complicated, and nobody was downloading plugins because too many steps. And now that we have this thing here, it's really much easier to have people downloading the different plugins. Okay, so this was for trackings. It's the same. You do exactly the same. Yeah, because when you are playing in 3D, you remember the ROI that you saw before. When you are doing it in 2D, in 3D, they do not appear the same. And it is In fact, you will have a call to your painter things, and it will provide you a graphic interface, and either you can deal with it, like here it's a graphics 2D, or you can have a VTK scene and you put whatever you want in it, or you can have, well, it's depending on the viewer. And this thing is extendable too, because we don't even know if you're going to add a new kind of viewer. But it works in 3D, yeah. And I'm not very happy with the rendering of the arrows that I made in 3D. It's not cool at all. Why are you laughing, Stephane? Yeah, it's a good topic. IC is not a concurrent of ImageJ. There is no story of switching at all. There are cousins, and in the open source field, you have things, and if one day there is a fork, or if people take different direction, it's because there is a problem about the addressing of the problem, because of the people that are using it, because of the people that don't want the same thing. But at some time, this thing, for all the project, all the times they will go back together. So Curtis was speaking about the architecture on the different houses and so on. It's a good thing, and if I had to push on it, you will never see one house that fits for everybody. So it's possible to have two very cool houses. And at some point, you see that the socket is the good design in one, and the other is going to copy it, and that's cool. If people want to copy a lot of things of IC or vice versa and so on, go for it. It is the main idea. Okay. I just want to, I will just show you, because people were asking about what is the coding party, and I would like to show you this. There is this little film about the coding party. So most of people are French, Swiss, or so sorry about the English. They are better than me, but and you will see the kind of project they are able to do in 2 or 3 days. Oh, by the way, you see the next logo. If you want to apply to the next coding party, we'll be happy to receive you. We cannot pay for everything, but
Displaying the live feed in the viewer window, and you can turn on live image processing.
so this guy is taking an image using a plugin for a webcam input. We have 3 different kinds. And then he put it in a protocol.
Implemented the reconstruction algorithm which is kind of the convolution for microscopy. So IC works now with a nice user interface and nice routines for the biologist, and it also runs in headless mode in ground cluster. So now I can easily put my code to IC all the
I'm sorry, but I need to explain you something in this. Well, okay, here. You see this interface, this GUI that is here. It's not the guy that designed this, because, well, it's pain to design this. So we just set a number of input and output, and we create it for him. And then if he launch it to a cluster, it's the same story as what you had before. We're going to send the argument to the plugin. Okay, so it can run headless. We build the GUI if we need it.
Microscopy. So IC works now with a nice user interface and nice routines for the biologist, and it also runs in headless mode in ground cluster. So now I can easily put my code to IC all the previous algorithm that we've been developing can easily be translated with this knowledge now. So we can also run it headless, and then it takes the same input image and output image, and then after some time it produces the result, which is safe for the hardware. Yeah, so it's done.
Thank you.
I will switch a little bit.
User interaction. So here we have an animation of deep block.
Yeah, this guy is playing with 3D.
So it's actually very happy to make things faster in terms of, for example, moving a snake to displace the snake. For example, if you go over a control point, you can drag it. You can.
So when he came to the coding party, he say, okay, Blender is like that. I like the same. Those people are from OpenBIS.
Plugins that integrate with the microscopy technology in OpenBIS and allow you to download images stored in OpenBIS, process them in IC, and maybe in the future store them back in.
So OpenBIS is a database.
And OpenBIS instance that plugs the microscopy technology. I'm not connecting to.
Okay, so if you want to know more, there is a film on the website, and well, it's very cool what can be performed in just 3 days. Okay, Stephane, you want to switch to the protocol thing? No, he doesn't want. No, but just to make one with the people so they can follow this. Okay.
But I think it will be very fast because it's very easy to do so.
So the idea of the protocol is to design a sort of complex workflow of image analysis and to re-execute them easily on several files. So I will show you quickly how to design it. Okay, so the main idea is that you have different blocks, then you link together to execute a more complex workflow. So Fabrice showed you a bit about them, but here is how the block presents. So you have a name which gives the purpose of this block. So here we have a hash kamin, which is a hierarchical kamin block, which is well, I won't explain in detail, but you give a minimum size and a maximum size of the object you want to detect, and it will process different segmentation until he finds an object fitting in the corresponding size. Okay, so we will open it together, and we will do it on a simple example. So you can open the protocol plugin on the LRCL.TIFF image. As this is this one we want to process. Okay. So here it is. So what we want to do is to just quantify the nucleus of this cell. So where is my image? Okay, that's it. Yeah. So we just want to find the nucleus in this image, and we will do it with the protocol. For this, we have different steps. First, we want to extract the channel of interest. Then maybe we want to process some filter of the image. Here the image is quite clean, but sometimes you have some noise, so you want to filter the image. Then we will find an intensity threshold to find the best value to detect the nuclei. Then we compute the threshold, extract the region of interest, and then do the quantification. So unlike the spot detector, we can see that here we try to separate different processing in the very, very smallest step. So it's very important to have this. So each block is very specialized to do a specific step, and so we do it naturally better. So for this, I know the protocol plugin, and I will use a first block to extract my channel. So for this, when we don't know the name of the block, we can directly type here in the search bar some keyword to find the block. So here, for instance, we want to extract the channel. So I will type extract. And then I can see a list of different blocks appearing here. When you have found the block that you want to use, the process which interests you, you can take it and drag it, drop it over the protocol workspace area. okay? And then the block appear. And so here, if I execute this protocol which has only one single block, it will extract my channel, but as I don't display the result, nothing appears. So what I need now is just to display the result. And for that, we have a simple block which is called display. So a quick remark, you can access all the block through a context menu here if you right click in the background of the workspace. So if you make the menu to appear, you will see that the display block is the last block in the menu. So if you click on it, it appears. And then you can connect the result of the extract channel block inside the display. Okay? And it creates a link. If you want to remove this link, you can just go over the link and click on the cross. So you see it's pretty easy to connect different blocks and to connect different processing together. So now if I execute it again, I just click on run. I have my result here. And if I double click in the display block, it directly opens the result inside IC. And like I see that I have extracted the first channel. Okay? So here, the channel we want to process is a nucleus channel, which is a blue one. So I have just to change the channel parameter to true, because the blue channel is a channel true. And I can execute again. And this time, you see that the result is different, and I have my blue channel. Okay? So we can go quicker now. So the next step is to clean the data. So for this, we will use a Gaussian filter block. We have different kind of filter, but here we just want to use the Gaussian one because it's enough for what we need to do. So again, you can just type Gaussian here, and you find the Gaussian filter and drag it over the protocol workspace. Okay, so now can you tell me how I have to connect the two blocks together? Which output I have to connect to which input? So I guess you know that I will use the extracted output from my extract channel because I want to process the channel 2. So I need to connect the extracted output from the input of the Gaussian filter. But which one? The first one. In the input one. Just there. Actually, you cannot make any mistake because you have the color, which indicates you that you have an image type field here, so you cannot connect to the other color. So if we do this, we will extract the channel, and then we will apply a Gaussian filter on the channel, on the image channel, and then here we have the output. So if we want to display the result, we just have to take the output and connect it to the display. You can see that it removes automatically the old link. Then we can reset the state of the protocol and run it again to verify that we have the expected result. So you cannot see the difference maybe, but we can see that the Gaussian filter is applied. Or not. It's not applied because actually my sigma has kept to 0. So it's why the difference was so no, there is no any difference. So this time, if I run it again, you can see that the filtering is correctly applied. Okay? So we will design quickly the world protocol to find what we want to do. So this time we will use a Chaumont threshold block. So this block doesn't compute the threshold itself, it will just find the value for the threshold. Okay, so we have 2 steps to compute the threshold. We first find the intensity, and then we have another block to compute the threshold. Okay, so Chaumont threshold. So this block uses an input, an image input. You can also select the channel where you want to compute the K-mean threshold, but here we don't have to change the parameter because we already have a single image channel, single channel image, and here we can select the number of classes for the K-mean. So the number of classes define how many groups you want to separate the histogram. So this is how the K-mean works. It just separates the histogram in different classes and try to find the best value for that. So if you want to separate the background from the foreground, we just have 2 classes. So we take this parameter, and you can see this time we don't have an image. We have a purple color here, so it means we have a value, numerical value. And so now we need another block to compute the thresholder. So of course you cannot guess automatically the name of this block. So actually they take the same name as the plugin. So if you use a plugin to do a specific processing, you can type the same name inside the protocol to find the attached block. So for instance, here we have the thresholder plugin. So if we tap thresholder, we will find threshold. Yeah, you can find the block corresponding to this plugin. Okay, so you can take the input directly from the previous block. This is not a result. This is just a simple bridge in this case because the input is not modified. But so instead of taking it from the Gaussian filter, you can directly take it from the previous block. It just makes the link less messy. And we will take the threshold value here and put it over the manual threshold. So instead of giving a manual threshold for the thresholder block, we take the value which has been computed through the K-mean threshold block. So we have a sort of automatic threshold. Okay? And then we can see that this block has 2 kinds of output. It gives us a binary output, which is an image, but we also have a raw output, which is a region of interest. So to start with, we will try with the binary output. So we reset the protocol, execute again, and you can see that the result is all black, but actually it works. It's just that the color map is not redefined, and we have a binary output, so we have only O and 1 value in the image. So if you want to see it, we have to double click on it. And this time we have the binary image appearing. Okay? So if you check the value in the image, you can see we have 0 value for the background and 1 for the object. So we are happy, but still we are not yet able to quantify really the nuclei. We have just the image. So what we can do, yeah. You? Okay. So what we can do is try to use the ROI instead. So the region of interest. So for this, what we want to do is to display the region of interest over the original image. So for this, we have a specific block which allows us to take the region of interest and put it over the original image or over an image. So this block is called add ROI to sequence, because a sequence is an image. We have to give the image where we want to put the ROI. So in this case, this is the original image. Et la cell. So we can take it from the first block, and we take the ROI from the thresholder block. Overwrite means that we will remove the previous ROI from the image. So we can check it. So if we run several times the protocol, we won't have many ROI appearing. So if I click on run, that is, I receive my ROI over my original image. The problem of this ROI is that it doesn't separate the different objects. I have a ROI, but a complete mask for as a binary image. So it's not very interesting still. So again, to have a better quantification, we have to use different blocks to to separate the object. So this time we will use another block which is called label extractor. So it corresponds to the label extractor plugin. What this block does, it actually takes a labeled image. So a labeled image can be a binary image, and we'll take the different objects and construct a region of interest from them. So I try to arrange a bit my protocol. So this time I use again the binary image, but I connect it to the label extractor. I can keep the default parameter because I know they work, and then I use the ROI from the label extractor. So the difference will be that it will separate the ROI, it will separate the different objects. So I take the ROI and I connect it to my add ROI to sequence block. Okay, so this time, if everything is correct, you should attempt this. And this time, it's a lot better because in the ROI panel here, you have directly the information about the different object. Still, that is not perfect.
I think we still have 10 minutes, so you see the ID, okay? Because you can leave him forever on this, and by the end, he will drive your car to your. I mean, it's okay. You have the.
You have a question? No?
Yeah. Yeah.
Yeah.
You can do this.
Yeah.
Oops.
Attends.
Ah bon, tu veux faire ton.
Yeah, I did. Yeah, you can change the name of the block, but that is not what we want to do here. But yeah, when you have done with a protocol, you can click on this embed, and you can see that you have different kind of embedding, but you can do some file batch processing. But you can embed in workflow, and workflow will just create in simple block. I reply on that, and then you can even reduce it here. If you collapse this block, you see it's very small. But you can also expose a variable this way. And then when you collapse it, you have a sort of new block which do a complex processing. And so you can use different complex blocks this way to make more complex. You have it. Yeah, you have a script block. Yeah. If you keep script,
and that's why for the last 10 minutes, I would like to show you very quickly the script editor, the bug reporter, and how to process with ImageJ, because we didn't see it.
But actually, the JavaScript block is very important because you don't have all the block for everything. Sometimes you will get some lock because you don't have a block which can do exactly what you want. In this case, you can use the JavaScript block and do whatever you want because the JavaScript gives access to almost everything. So it's very important to know that you have this possibility. And so maybe, no, it doesn't any more questions, so it's okay.
It's okay?
It's okay for me.
You had a question?
No,
it's
I
okay.
think you don't. You still have your question or not? Yeah.
Yeah.
To save the workflow? Yeah. When you save it, it generates a XML file. It's just a XML file that you can exchange with someone else, and then if you try to load the XML file on another computer, which don't have the necessary plugin, for instance, it will install it automatically for you. So normally you will be able to execute any protocol on any other computer without any problem. Okay.
But the question, if the question is, can you generate it? You can also do it, yeah, programmatically.
Yeah. Normally it should be backward compatible. We try to preserve the compatibility with our protocol, of course, because we publish them online. So imagine that we publish a protocol online, then later, 1 year later, you try to open it, it doesn't work anymore.
we store all the version of all the protocol, but also all the plugins that the protocol is going to use. So you can take a snapshot of all the plugin of a specific date and an IC of this specific date, so you do exactly the same. But if your question is, can I take something from a specific date and make it compatible with something from another date and communicate together, you will have a little problem at the bridge. But okay, I just want to show you a few things. This one, if IC crash, I'm sorry, it didn't crash. So this, you will have this. It's a bug report, and you can say whatever you want in here. You can put your email, your report, and then I have an email because I'm the author of the plugin bug, and it is here, bug report. Okay, and you say that somebody generate a bug, and I have Java null pointer exception, and the error is at generate a bug line 32. So I can correct it, and I will never do it because it is this bug thing. But the idea is that we harass the developer so that you get a better reliability on the usage of your plugin, because we send them those email. But the idea is just to correct them, of course. It's the other thing I want to show is the communication with ImageJ, because it's the main focus here. I'm too stupid to forget about this. So I take this one again, and let's say I have this row here, and I want to play with ImageJ. So I go to ImageJ tab. This is the pure ImageJ one. We switch to detach mode here. So we have a lot of window. You see, I asked Stephane to make it a full window because it's always a mess on my desktop. And by the way, you can play with IC this way, we should have several screens. And then you say, I want to do something in ImageJ with this. So convert to ImageJ, and now you are 100% in ImageJ. And you can do whatever you want, like, no, find edges, okay. And when you're done, you click here and you're back to IC. And I don't understand why I have not the ROI. I should have the ROI here back too. Okay. Okay. So you see the ID. And if you create a protocol, there is a box called call ImageJ plugin. And then it comes into it. It calls the macros, the whatever you want in ImageJ. And then it will grab the result if the result can be grabbed. So if it is a new image, for instance. You can also call ImageJ plugins through scripts, and then you can go back to the classical IC like that. And in ImageJ2, as the format is exposing the input and the output, potentially we can use the ImageJ2 as a lib in IC and keep ImageJ1 and put the ImageJ2 plugins as a protocol as you saw before. And now I just want to show you the script, and I'm done very, very fast because we had a lot of effort on this. So if I want, let's say I have a sequence, just to show you how easy it is. So you don't know anything about the scripting, and you want to get the active sequence in an object that is called sequence. So you get sequence, and you see it looks like I killed a trainee to do this, and it looks like in Eclipse. And then you want to get the name, type sec dot get name, and you have it. And if you want to print it, you do this, and you see the error here on the left because I didn't put my bracket. And then you press play, and you see ps7.jpg. And this is if you want to, let's say you want to perform a crop, or I don't know, you type sequence util, and here I'm going to load a library. I press enter, and then the import is made. You see at the top. And then you press dot, and you say you want to extract a channel of my sequence sec. And the channel I want to extract is channel number 1. And now I want to, this is going to be my sequence 2. and I want to display this sequence too. Up. Add sequence 2, and then I press play. Up, and it works. See? And if you install a plugin, it will be this easy to access the capability of the plugin. So really huge effort on the scripting. It's not a specific language, it's really JavaScript. And if you want to switch to another things, you click here. But here I didn't install Python, but if you do this, Python, I click here. Oops, sorry. So Python. Where is it? Yeah, it is this one. Jton for IC. So it's downloading it. You see it here. So I need to wait a little bit because there is dependencies. But when it's finished, in here in the list, I will have the Python. And if you want to add another language, you put it as a plugin, same thing, and you will have it in the end. Okay, but here it's downloading 10 things because there is a lot of dependencies. And that's all. And if you want to finish with very, very, very last film, yeah. No. Because it is the same question as for the undo. We didn't find a way to record efficiently everything. And it brings frustration because if the plugin is not created to be compatible with the macro, it doesn't work. But we will work on this if people are keeping asking. And we have a poster after if you want to ask questions. And here is my teasing for the poster. Once upon a time, a biologist was observing some person. He recorded his images on his computer and started to quantify them manually. Very soon, he had good results. He was very happy and reported to his boss. His boss was very happy too and asked if the statistics were relevant. They were not. So, the biologist went back to the microscope and took thousands of images. Very soon, he realized he had too many images to measure. So, he decided to go to the IC Club, which is open every Wednesday morning at the Image Analysis Unit, to get some help. After a while, these two guys understood each other, and the geeks found a mathematical method to automate the analysis. The geek wrote some computer code, and the biologist downloaded the software and performed the analysis directly on his computer. Results were relevant, so he could write a really good paper. He sent his paper to the editor that sent it to the reviewer. They were all able to rerun and control the results by downloading the same program. In this story, all actors were able to communicate and work together thanks to IC. Come at how postered no more, and next Wednesday, and the next, and the next. Thank you very much.